Hello students, welcome back to the video on the topic of hashing. The subject is data structure and application and the subject code is BCS 304. So in this I'll be talking about collision resolution technique. In the previous videos, okay, you can go back and check the previous video. I have talked about hashing, the different types of hash functions. I have also talked about the different types of hashing techniques that are available. In this video, I will be talking about the collision resolution technique. So before I go to the collision resolution, first let us look at what is meant by collision. So what causes collision? And then we will look at solution for collision. So if the collision happens, what to do? How can we, overcome it? So before going to the resolution, first let us look at what is collision itself. See here, in this example, I have taken one example over here. I want to insert the elements 22, 32, 43 and 65 into a hash table. And we have assumed that the hash table size is 5. So if the hash table size is 5, so I'll draw the hash table like this. So 5, okay, so 0, 1, 2, 3 and 4. Okay, I have given the indexes. Okay, now I will use the division method. So it is 22 mod 10. 22 mod 10 is 2, because when I divide 22 by 10, I will be getting the remainder as 2. So I'll be using that. This means that at the second uh, position, I will have to keep the element 22. Likewise, 32. So 32 mod 10. 32 mod 10 is, if you're confused, it goes like this. So 32 mod 10. So you'll have to divide. So 10 times 3 is 30. So when you subtract, you're getting the value 2. That means in the second position, I will have to place the value 32. But if you see, the second position is already occupied by the element called as 22. Okay. Now what to do? Because 32 is also mapping to the second index itself, right? The hash key generated is pointing to 2 itself. It's 2, right? Now what to do? So I can't place 32 because 22 is already present. So that leads to a situation called as collision. When an element is already present in the particular index of the hash table and you want to insert another element, when the hash function is found for that element, it is pointing to the same location as a other value that is already present. This leads to a situation called as collision. Now, what to do if collision happens? See here, I have listed down 5 techniques through which we can resolve the collision. So in this video, I will be talking about all the 5 techniques. The first one is collision resolution by linear probing, and second one is quadratic probing. Third is double hashing. Fourth one is rehashing, and fifth one is chaining. When you look at the old question papers of data structures, when the topic of hashing is involved, usually there will be a question on collision resolution. So you have to learn these techniques. Not only as in you learn, you understand the concept and you also know how to resolve the collision manually using all of these techniques. So first one is, I have taken the first topic, the first technique, that is collision resolution by linear probing, also known as open addressing. See here, I have given the explanation. Let me read it out for you. Some might understand, some might get confused. If you're getting confused, I will explain all these things. Okay, see, suppose there is a new record R. Okay, I want to insert and record R into the hash table. Its key is K. Okay, there's a record R whose key is K, and this is added to the table T. Okay, we want to add a record R, okay, which is having the key K into the table T. But we see that, okay, that particular value is already filled. Okay, so K is already mapped to a given one more element. Now what to do? So one way to avoid collision is to redesign the R to the first available location following the T of H. We assume that T with M location is circular, so T of 1 comes after T of M. That means here in this case, when you have, for example, 5, the hash table size is 5. So the indexes will be 0, 1, 2, 3, 4, right? So after 4, if you want to insert one more element, you will have to go back to 0. That is what. It's like a circular list. According to the procedure, we search for the record R in the table T by linearly searching the location T of H plus 1 until we meet an empty location or finding the R. Now, what do you mean by all this? Let us take up an example, and with that example, I'll show you what this paragraph means. See here, I have taken an example. Okay, so consider a hash table of size 10. Use linear probing to insert the key 72, 27, 36, 24, 63, 81, 92, and 101 into the hash table. And they have also given use the hash function h of k is equal to k mod m. Now, what you're supposed to do is you have to insert one element at a time. See, initially at step 0, nothing will be present in the hash table. The hash table contents are empty. So, we will represent that using minus 1. Minus 1. Okay. Now, in the step 1, let's insert the first element, that is 72. So, I want to find h of 72, which is 72 mod 10. 72 mod 10. 72 mod 10 is 2. Correct? So what does this mean? In the second index of the hash table, you place the value 72. So 72 will come here. Okay. Rest of the values untouched. Everything will be minus 1. Okay. Everything else is minus 1. Likewise, let's try to insert the next element. Next element is 27. Next element is 27. So let us try to insert that element. Now, can you tell me what is 27 mod 10? 27 mod 10. So here I will try to insert 27. So h of k is h of 27, which is 27 mod 10. 27 mod 10 is 7. Now at the 7th position, I have to insert the value 27. So 27 is inserted here. And 72 was already present in 2. So other elements minus 1. Like this. Okay. So till now we have not encountered any collision. Good. So let us check for the next element. Next element is 36. Next element is 36. So it is, I want to insert the value 36. So it is 36 mod 10. 36 mod 10 is 6. Correct? So at the 6th position, I am keeping 36. 7th, I already have 27. And in the second, I have 72. Rest of the positions still have nothing. So it is denoted by minus 1. Okay, next is 24. Next element is 24. You can look at the question. These are the elements. Okay, so 24 mod 10, which is equal to 4. 24 mod 10 is 4. So at the 4th position, 24. In the second position, 72. 6th position, 36. 7th position, 27. Rest of the places empty. Rest of the places are empty. Okay. Now, step number 5. Step number 5 is 63. 63. Okay. So I will insert 63. So it is 63 mod 10, which is equal to 3. 63 mod 10 is 3. So in the third position, put the value 63. In the second position, we have 72. In the fourth position, we have 24. In the sixth position, we have 36. In the seventh position, we have 27. These values are from the previous steps. Okay. Rest of the steps, nothing. Now take the next element. After 63, we have 81. So try to insert 81. So 81 mod 10, no problem. 81 mod 10 is 1. So at the first position, 81. Rest of the elements, you place it. Now I think you have understood. So it shouldn't be difficult. We have not encountered a collision till now. Okay. Now let us do the next element. Next element is 81. 81 is done, sorry. Now 92. 92. Okay, so 92 mod 10. 92 mod 10 is 2. 92 mod 10 is 2. Let me place the elements, okay, before 92. So it is this one minus 1, 81, 72, 63, 24, minus 1, 36, 27, minus 1, minus 1. Now 92 mod 10 is having the value 2, but can you see 2 is already filled by 72. 2 is already filled by 72. Now what to do? This has led to a situation called as collision. Are you understanding? This has led to collision. Because at the second position where the hash key generated is 2, in that position already an element is present. So now we will make use of linear probing. What linear probing will do is, it will check for the next available position. Next, it will go to the next position and check whether it is empty. See, uh, 1 second, okay? So it will try to check for the next position. See, 72 is already filled, right, in that two positions. So it will go to 3. If 3 is already filled, 4 is already filled, but what about the fifth position? As you can see, fifth is empty. Fifth is having minus 1. So what happens is, this 51, this fifth position will now be replaced by the value 92. So what happens is, if there is a collision that is happening at a given position, it will go to the next position and try to place itself over there. And if the next position is also filled, then it will go on searching for the empty place. Are you understanding the idea? Now, next one is 101. Last value, 101. Okay, so I have taken, I think, almost all the values. So 81, 72, 63, 24, 92, 36. Okay, now let us look at 101. See 101. So 10 mod 10. 10 mod 10 is 1. Okay, so before insertion, the elements were looking like this. So minus 1, 81, 72, 63, 24, 92, 36, 27, minus 1, minus 1. So this is 1, but here 1 is already filled by 81. So it will go to second position. Second position is 72 already filled. Next is 63 already filled. Fourth position 24 already filled. Fifth position is filled by 92. Sixth is filled by 36. Seventh is filled by 27. Eighth place. Look at the eighth place. Eighth place is empty. So what will happen is, this 101 will be placed in the eighth position. So 101 will come here. I hope you have understood. This is how this step, this particular method, right? It's not that complicated actually. It's easier to understand. The idea is, if the collision happens, you try to find the next position. Like as in life, see, when you're facing the problem, what do? Okay, sometimes we try to run away from it, or we try to find the best way to face it, or you know, come out of it, right? So here also like that only. When the collision happen, it is not worrying. It is trying to find the next position. When the collision occurs, that means a given box to it is already filled. So it will not be like, it will not like worry, okay, this place is empty. What this place is already filled. So what to do? It will find an alternate, position which is free. That is what the concept of linear probing is. After this, once you do this table, okay, you will have to fill this particular table over here. Keys, home addresses, and key addresses. Key addresses are the indexes. So you have 10 elements. Sorry, you have 10 elements. So I have written the key addresses like this from 0 to 9. Okay. So see here. Okay. Um, First element is what? First element that we have in the, see the first element that you have at this particular one here. So 81 will come here. See, zeroth position is not having anything. So key is also empty, home address also empty, search length is also empty. Whereas the next element 1 is having 81. Is it supposed to be at 81 only? Is it supposed to be at 81? Yes, no collision has occurred. So it's at 81. Okay. Now, what you're supposed to do for the next element? Next element that we have is 72. Correct? 72. 72 is now its actual, it was mapped to 2, right? And it is also present in 2 itself. So keep it like this. Likewise, for 63. 63, its hash value is 3 and it is placed at 3 itself. So no problem. 24, its mapped value is 4 and it is placed in 4 itself. But when it comes to 92, if you remember, 92, you were supposed to be placed at 2, right? It is supposed to be placed at 2. But where is it actually placed? It is placed at 5. So what we have done is, see here, 92 was supposed to be here, but it is over here, right? So count. So from 2 to, see, 2 is 1. When you take that position also, 2 is 1, 3 is 2, 4 is 3, and 5 is 4. So from 2 to 5, how many positions are there? 4 positions are there. So put that search length is 4. Likewise, 36 was supposed to be at the 6th position. It is at 6th only. Likewise, 27. 27 is supposed to be at 7. It is at 7 itself. 101. 101 was supposed to be at first place, but it is at the 8th place currently. So how much did we need to map? We needed 8. Ninth one is still empty. Ninth one is empty, right? So I kept it like this. Okay. So this is how you will carry out the linear probing. So the very popular and most commonly asked question. So if they ask you to explain with the help of an example, you need not take such a big example. You can take 4 or 5 digits and explain. The idea is, you place the element when you, identify the digits. Make sure that 2 digits have the same hash value, and then you can show the collision and how the collision can be resolved. I hope it is clear. This is all about the first method, the collision resolution using linear probing. The next method is quadratic probing. This is also a very interesting variation of linear probing. See, in linear probing, what used to happen if a position is filled, we find the next position, right? Here, what happens is, instead of finding the see, if 1 was filled, then we will check whether 2 is, if it is like this, okay? If 1 is filled, and 2 is still, 3 is also empty, then if 1 is filled, we try to place the element in the second position in case of linear probing. Whereas in case of quadratic probing, if 1 is filled, okay, if 1 is already filled, instead of going to the second position, we go to the square of the given position. What does that mean? Let us look at that with the help of an example. See, consider a hash table with the size 7. Use quadratic probing. Using the quadratic probing, insert the following elements 10, 22, 31, 52, and 73. First thing is, in case of quadratic probing is, don't worry, just what you do is, you find the position, that is, you find, see, size is 7, okay. So what you do is, find as it is 10 mod 7. 10 mod 7 you do, okay. 10 mod 7 is 3, okay. So draw the table. Table is having 7 size, right? So 0, 1, 2, 3, 4, 5, and 6. In the position 3, you place 10. In the position 3, you place 10. Okay. Other places, initially everything will be empty. So like this, in the position 3, you place 10. So, sorry, this is minus 1, minus 1, minus 1. Now take the next element 22. So it is 22 mod 7. What is 22 mod 7? 22 mod 7 is 1. Correct? 22 mod 7 is 1. Like this it is. 22, 7. 7 3 times 21. When you subtract, you're getting the remainder as 1. So in the first position. So again, draw the table. So 0, 1, 2, 3, 4, 5, and 6. Like this. So at 3, you have 10. Now at 1, you will have 22. The rest of the places empty. Like this. Take the next element 31. 31 mod 7. 31 mod 7 is real value is 28. So you will get the value as 3. Okay, now we'll try to insert the value into that position. So 0, 1, 2, 3, 4, 5, and 6. So 22 is already present, 10 is present. Rest of the elements are minus 1, minus 1, minus 1, minus 1. Now, can you place 31 at position 3? You can't place, because at the position 3, you already have the element called as 10. Now, what to do? If it was linear probing, it would go to the next location, that is 4, and it will place itself over there. But that can't be done over here. Okay. So, what to do? Now I told you that we will have to we have to square the hash function, something I had told, right? So what we will do is, see, this one is occupied. Correct? This is occupied. Now what to do? What you do is, okay, now what you do is, instead of doing, going to the next location, whatever value you get, the hash value you got is 3, right? Plus, okay, first time you take the value 1, square it, 1 square. So it will be then mod 7. Do this quadratic hashing. So take the hash value and the first integer. So the first positive integer. So 1. Okay. Then it would be, see, next time if you have one more collision, then it would be 2 square. Then it will be 3 square and so on. Okay. So here, do this. So it is 3 plus 1 mod 7, which is 3 mod 7. Sorry, 3, it is not 3, it is 4 mod 7, which is equal to 4. Now what you do is, at the fourth position, you place the value 31. Are you clear? We'll do the next for the next element, then it will become much more clearer. See 31, then you have 52. So it is 52 mod 10. 52 mod 10 is 52, not, it is not mod 10, sorry, it is mod 7. 52 mod 7. 52 mod 7 is 49. This is the nearest value. So 50, 51, 52. So this is also becoming 3. But if you look at 3, 3 is already filled by 10, right? So what you have to do? Take that hash value and use the first number and its square. Mod 7. So it will be 4 mod 7. 4 mod 7 is still, 4 mod 7 is 4. But 4 is also occupied. 4 is occupied by 31. So still there is a collision, right? Still there is a collision. Now what to do? Again take the same hash value 3. Now 1 would become 2. So 2 square. Okay, mod 7. So it is 3 plus 4 mod 7, which is 7 mod 7, which is equal to 0. So this means that 52, see, look at 0. 0, is it empty? Yes, 0 is empty. So take and place the value 52 at the 0th position. So this is how it is going to look like. So 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so at the 0th position, place 52. First position you have 22. Third position you have 10. Fourth position you have 31. Rest of the places empty. Did you understand? Here is where the trick is. Now let us do the last one, 73. 73. So I'll do 73 mod 7. I'm getting the value 3. Again 3 is filled. So 3 plus 1 square mod 7, which is again going to be 4. 4 is also filled, right? 4 is also filled. So still collision is there. So what I will do is, I'll do 3 plus 2 square. 3 plus 2 square is 7 itself. It is 3 plus 4 mod 7, which is equal to 7 mod 7, which is equal to 0. But 0 is also filled. So again collision. So what you have to do? Now 3 plus this 2 will now become 3. So 3 square mod 7, which is 3 plus 9 mod 7. 3 plus 9 is 12. 12 mod 7, which is equal to 5, right? 12 mod 7 is 5. So 12 mod 7, 3 plus 9. So 3 plus 9 is, yeah. So mod 7 is 5. So at the fifth position, you can place, at the fifth position, you can place the value. Oh God, wait. Okay, it is sort of stuck. Just a second. Okay. Let me try to figure out. Okay. What I will do is, I will write the table for 72, 73 over here. So it will be like this. So 0, 1, 2, 3, 4, 5, and 6. And now 0 is filled by 52. 1 is filled by 22. 2 is empty. 3 is 10. 4 is 31. 5 is filled by 73. Here there is no 7, okay, only till 6. So here like this. This is how you can carry out the quadratic probing. That is, instead of just looking for the next location, you find the new hash value by taking the square of a given number. So first time it will be 1 square, then 2 square, then 3 square. Your hash value that has caused the collision plus the positive number. Okay, so 1 square, 2 square, 3 square, and so on. So you can look at this. You can look at this and you can learn quadratic probing. I hope it is clear. Okay, third technique, double hashing. This one, okay, double hashing is also asked a lot. So let us look at this one. See, it says in double hashing, we use two hash functions rather than a single function. Okay, so instead of using one function, we are going to use two functions. Double hashing uses the idea of applying a second hash function to the key when a collision occurs. So when the collision occurs, what we do is we apply another hash function so that we can overcome the collision. The result of the second function will be the number of the position from the point of collision to insert. Now, when you select the second function, the second hash function, there are some points that you have to note. It must never evaluate to 0. And also you have to make sure that all the cells can be probed. And a popular second hash function is hash 2 of key is m minus key mod m, where m is the nearest prime number. And it should be smaller than the total size of the hash table. I'll explain all this with the help of an example. Okay, so what I will do is first I will show you what formula we usually use in order to calculate the hash function in case of the double hashing. See, I am finding the hash function for a given key. I will show you how I can use hash function 1 and 2. So it is h1, this is your first hash function, plus I star h2 of k mod the total table size. You might be wondering what this I is, okay? I will have value 0, 1, 2 up to n. I will explain this, okay? When I take up an example, I will explain. So in this h1 of k is whatever k mod table underscore size. This is how we usually used to do, right? K mod table underscore size. But the interesting part is with h2 of k. h2 of k is the nearest prime number minus k mod that same prime number. Now, what prime number am I talking about? See, suppose the table size is 5. Suppose the table size is 5. Then its prime would be, when you're calculating the second hash function, the prime number will be a number which is smaller than 5 and also its nearest prime number. So I have between, see, these are the numbers I have, right, which are smaller than 5. So the nearest number I have is 4, but 4 is not the prime number. So when it comes to the third, this particular element, 3 is a prime number, right? So this will be considered here, 3 and 3, like this. Are you clear? Don't get confused. Listen to the explanation carefully and understand. Now, I will show you with the help of an example how this works. You have to remember this formula, okay? Not that hard, right? It is first hash function plus I times the second hash function divided by the total table size. Whereas H1, I think, is easy to find. It is your key divided by the, not divided, it is modulus the table size. Whereas H2 of k is prime minus k mod prime, this one prime number. Okay, see, I'll take up an example. Assume the table size is 10. Assume the table size is 10. Apply double hashing. Apply double hashing on the following elements. In case of the collision, okay. So 22, 32, 44, and 54. Now let us try to apply we'll find the hash function, okay. So initially, you remember the table would be there. The table would be there. And I told you the table is of the size. In this particular problem, they have given the table is of size 10. So 0 to 9. For the convenience of drawing, so many times I'll have to draw the same table. So what I will do is, for now, in this particular example, I will not redraw the table again and again. I'll keep one table as a common one. Okay. So the first element that we have to insert is 22. Correct? So I will take that formula. If you remember, it is h of k is h1 of k star, sorry, not star, plus I star h2 of k mod table underscore size. Like this. So it is h of 22 plus I will start at 0, 1, 2, 3. So initially I will be 0. I star h2 of 22. This is h1 of 22. Then h2 of 22 mod table underscore size. Correct? This part would become empty or 0, right? Because anything to a 0 is 0. So it is h1 of 22 plus 0 mod table underscore size. So this is h of 22 is 22 mod 10, 22 mod 10, modulus table underscore size. Table underscore size is also 10. Correct? So it is 22 mod 10, which is 2. Again mod 10. Again it is 2 itself. So what you are supposed to do? Place this 22 here. I hope this part is clear. While inserting the first element 22. Next I will try to insert the next element 32. See 32. So 32. So h of 32 is h1 of 32 plus I initially is 0. So 0, it is 0 times h2 of 32 mod table underscore size, which is 10. Again, this part will become 0. It is h1 of 32 mod 10. h1 of 32 means again it is 32 mod 10. Okay, again this is this part. This is this part. Okay, so it is 2 mod 10, which is again equal to 2. Are you now understanding what this is happening? See, I used initially, I have used, see, I have used it as 0 and I've got the value as 2. But if you see here, 2 is already filled by 22. Now what you have to do is, instead of using the I value as 0, change the I value to 1, increment it. So it is H1 of 32 plus 1 into H1 of the H2 of 32 mod 10. So H1 is 32 mod 10, this part, plus 1 star. So if it is 10, 10's nearest prime number. So 10 is there, okay? Its nearest prime number. Its nearest prime number is 7, right? The smallest, because H2, if you remember, H2 is whatever prime number you have minus K mod prime. This formula you have to use. Okay, so it is 7 minus 30, 7 minus 32 mod 7. Okay, this whole thing you will have to mod 10. Okay, so this is 2 plus 1 star. 32 mod 7 is how much? 32 mod 7 is 4, right? 4. So it is 7 minus 4 mod 10. Calculations are there, but calculations are not that hard. So 7 minus 4 is 3. So 1 times 3. So it is like this. Okay, so 2 plus 3 is 5. So 5 mod 10. 5 mod 10 is 5. Now you have got the valid location. 5 is empty. So 32 will be placed at 5. Okay, similarly, the next value that I have is 44. So 44. So it is H1 of 44. That I part is 0, right? So I'm ignoring that entire thing. I hope you now understand, just to, simplify the steps. So it is 44 mod 10, which is equal to 44 mod 10, again mod 10, total size. So it is 4. So 44 will be placed at 4th position. When it comes to the next element, 54, so 54, it is for 54, initially we'll do the H of 54, which is H1 of 54 plus I star H2 of 54 mod 10. 10 is the same table size, right? So it is 54 mod 10, this part, okay? Whereas I value is 0, right? So it is 0 times H2 of 54. I will not write this entire thing because anyways it will be 0 only, right? So that is why. So it is 54 mod 10 mod 10. So it will lead to 4. Correct? But 4 is already occupied by 44. So now what you have to do, if you have understood the step, I has to be incremented by 1. So it is H1 of 54 plus I times H2 of 54 mod 10, which is equal to 54 mod 10. Okay, 54 mod 10 plus 1 times. Okay, K is 54. Sorry, K, no, it is 1 star here. It is prime minus. Prime is how much? Nearest prime is 7. 7 minus 7 minus 7 minus K mod K mod prime. So K mod, so 54 mod 7. The whole thing has to be divided by 10. Okay, let's. So 54 mod 10 is 4 plus this part. 54 mod 7. The nearest value is how much? For 54. So 54 is 7 times 7, right? 49. So, so this will become 5, right? Is 5 empty? 5 is also not empty. See, this will become 5. So it is 1 times 7 minus 5. Okay, mod 10. So it is 4 plus 7 minus 2, which is 2 mod 10, which is 6 mod 10, which is equal to 6. Now you have got the position. So 54, can it be placed at 6th position? So check, okay. 54 can be placed at 6th position. So 54 will come here. Other position is left empty because nothing to be filled. I hope you have understood the method. You just have to remember that formula, and according to that, you will have to do the calculation. So what you do is you take up your own set of example. I'll take you take the screenshot. I think I will have to minimize a bit more. Yeah. Now you can take a screenshot of this and practice and check if you're getting the right answer. Okay. If the collision happens, just take the I value, you increase the I value by 1 and do the calculation. I hope you have understood. We'll look at the fourth technique and the fifth technique that is present. Okay, let us continue the topic of rehashing the collision resolution. So the fourth technique is called as rehashing. So rehashing, that means hashing again. Rehashing. So what this the explanation says is when the hash table becomes nearly full, when it becomes nearly full, the number of collision increases, right? And the table is almost full and you want to insert an element, the chances of collisions are more, thereby degrading the performance of the insertion and search operations. In such cases, a better option is to create a new hash table with the size double the size of the original hash table. Okay, when you have a hash table and most of the values are filled in it and you want to insert another value, it might lead to a lot of collision. So what we will do is we will increase the size of the hash table. We will double the size of the hash table, but it is not exactly doubling. Some minute calculation is there that needs to be done. Okay. All the entries in the original hash table will then have to be moved to the new hash table. This is by taking each entry, computing its new hash value, and then inserting it in the new hash table. Though rehashing seems to be a simple process, it is quite expensive and must therefore not be done frequently. So I will take up an example and explain this method to you when the rehashing has to be done. See one example for rehashing. Okay, example, apply rehashing on 13, 15, 26, 6, 23, 24, and 7. Assume table size is 7. Okay, so what we will do is we will first do 13 mod 7. 13 mod 7 will give me 6, right? That is 6, that is 7. So 7 is the nearest to, so like this, right? 13, 7. So 7 times 1, the nearest, so 6, okay? So 6 will be the value. So you draw the hash table here. You draw the hash table. 7 elements. So the indexes are 0, 1, 2, 3, 4, 5, and 6. Okay, now in the sixth position, you place this 13. Next, we have 15. So 15 mod 7. 15 mod 7 is 1. So 15 will be placed here. Then we have 26 mod 7. 26 mod 7 is, so 26 mod 7. So 7 times 3, 21. So 5. So in the fifth position, place 26. Then we have 6. 6 mod 7. Okay, just a second. Okay. 26 mod 7. 26 mod 7 is 5. So it is placed here. So next is 6 mod 7, which is equal to 6. 6 mod 7 is 6, but 6 is already having the value. So you make use here, the collision happens. Here the collision has occurred. Now what you do is you use linear probing. So 6 is already occupied. So find the next position. After 6, you will have to go back to the 0th one. So 6 will be placed here. Likewise, 23. 23 mod 7. 23 mod 7 is going to give me 2. So here 23 will come. Then 24 mod 7. 24 mod 7 is 24 mod 7 is 3. So 24 will come here. Then we have 7 mod 7. 7 mod 7 is 0. Then if you apply linear probing also, you will have to apply that linear probing multiple times. See, first here, then here, then here, then here, then you might get this location. So this process is quite expensive, right? I mean, when the collision appears, when the collision occurs, this method is not so feasible. See, most of the values are already filled, so only one place is left out. If you try to do rehashing, rehashing itself will take a lot of time. Rehashing as in placing the element in the next available position. So what we do in such cases, we double the size of the table. See, right now the table size is 7. What we do is we double it. We double means you think that the table would become 14 now? The hash table size, no. You will have to increase it, double it, and check whether the doubled number is a prime number. It has to be a prime number. So 14 is not a prime number. So check the next number. After 14, we have 15. Is 15 a prime number? No. Then we have 16. Is 16 a prime number? No. Then what do we have? 17. Is 17 a prime number? Yes. So the new table will have the size of 17. Okay. So what you do is now you redraw. Now it will have 17 values. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, then 11, 12, 13, 14, 15, and 16. Like this. Now again you will have to do the rehashing. 13 mod 17. 13 mod 17 is the new hash table size. So 13 mod 17. Okay, so 13 modulus 17, which is equal to 30. So in the 13th position, place 13. Then you have 15. So 15 mod 17, which is again equal to 15. So 15 will come here. Then we have 26. 26 mod 17. So 26 mod 17. So 17. 26, 1, 7. So 1, 1, 16. So I think it is 9, right? 9. So at the ninth position, place 26. Then 6, 6 mod 17. So it is 6 itself. So here place 17. Then 23 mod 17. Okay, so this is also going to be 6 itself, but 6 is already filled. So next position you keep the element. Likewise, 24 mod 17. I think it is 8, right? 17 and 7. Sorry, it is 7. 7 is already filled. So in the eighth position you place. Likewise, 7 mod 17. So again, it is 7 itself, but these places. See, the idea is steps will become more. You will have to do the rehashing again, doubling the size of the hash table, and not only doubling, checking whether the new hash table size is a prime number. All these things are there. So this particular method is not that feasible, but this is done. Okay, you will have to know this method. So in the rehashing, when the hash table is almost filled and you want to fill one more element to it, what you do is you increase the hash table size by you double the size of the hash table and then do the rehashing on the all the original elements and try to fit into the table. If the collision occurs, then you follow the method of linear probing and find the next available location. Okay, this is the process of the fourth technique, that is rehashing. Let us continue the topic. Now we have the fifth and the last collision resolution technique, that is called as chaining. See, it says chaining technique avoids collision using an array of linked list. Okay, if more than one key has the same hash value, then all the keys will be inserted at the end of the list. Okay, one after the other, and thus the collision is avoided. We make use of linked list. So node will be present. In the node, you place one value, and one more node also, if it is having the same hash value, then you make it as the continuation of it. Okay, we will look at one of the example and we'll try to do the chaining part. See, it says construct a chaining hash table of the size and store the words like a, tree, you first, and so on. And uh, we have the hash function here as hash function is everything, then you divide it by the table size. Okay, all the letters divided by the table size, and the hash address is whatever sum you have mod 5. See, what you have to do is, see, first word is h of like, isn't it? So what you have to do is find the position of L, the Like, find the position of L in the English language. So L is having the position 12, sorry, L is having the position 12 plus I is having the position 9, K is having the position 11, and E is having the position 5. All this modulus the table size. Table size is 5 here, which I'm getting the value as 2. Are you understanding? Okay. Likewise, if I have to take the next letter is only A. Next letter is only A. It is happening. Okay. Next letter is only A. So it is H of A. What is H of A? A is the very first letter. So it is 1 mod 5. 1 mod 5 is 1 itself. Now what you do is you construct the hash table like this. Construct the hash table. Give the indexes 0, 1, 2, 3, and 4. This is not required. The last one is not required. Okay, let me redraw. 0, 1, 2, 3, and 4. 0, 1, 2, 3, and 4. Like this. What you do is to see like is getting the hash value as 2. So from here, you draw a node like this. This will have like. Likewise, A, it is pointed out by 1, right? So A will come here. Likewise, see, for tree, hash value is 3. So in 3, you will be writing tree. Likewise, for U, it is 1. U is 1. So 1 is already occupied. So you don't have to worry. Here you have to draw a node, and here you will have to write U here like this. Then you have first. First is having the hash value 2. So here first will come. Okay. Then again A is already shown, so need not do it. Then place is 2. So place, here it will be place. Then 2 is at 0. This is 2. Then when they end, you will have to show the list empty like this. This is how you will do the chaining method. You will have to do the linked list. If they ask you about chaining, you can draw this, and even if it is numbers also, you need not worry. Numbers means you can directly see if they tell like, 20, 12, 15 like this, then you need not do anything. You directly do the this division method, find the hash value, and according to the hash value, you place it over here. Suppose I want to insert 12 and 22. So it is 12 mod 5 is 2. So it will be 0, 1, 2, 3, and 4, right? 3 and 4. So at the second position, you will have 12. Then if you have 22, 22 mod 5 is again 2. So what you will do? From here, you will continue like this. Okay. So this is how you will do the chaining method. Chaining this collision resolution. So let us recall the things we have learned. We have learned a lot of things. Don't get confused. Okay. Don't get confused. See here. What is collision is also there. Collision resolution technique. What is collision? So you can take a screenshot of all these slides. So first is what is collision. Then we have the different collision techniques. I have listed out the different collision techniques. In that first one is using linear probing. Let me minimize the screen so that you can take a screenshot. So yeah, this is the first method. Then the second method. This is the second method. Quadratic probing. Third one, double hashing. Let me, this method is slightly, I have written it in that way. So yeah, double hashing. Fourth method, rehashing. Fourth method, rehashing. And the fifth method, that is chaining. Okay, so go through the video correctly and learn about the various collision resolution techniques. Thank you so much. In the next video, we will discuss some other topic on data structure.